model expressions using pictorial representations. So we're going to show you how you can use tiles and different models to distribute or combine like terms. So this first expression is 2 parentheses 3x plus 1 close parentheses. And one way that we can simplify distribution or show distribution using tiles is to take the number that is outside of the parentheses, which in this case is the 2. Okay, take the number that is outside the parentheses, and that tells you how many groups to make. So in this case, we are making 2 groups. Here's one group, and here's one group of 3x plus 1. So each group has 3 positive x's and 1 positive 1. So that would be one way to show this expression. Now, there are other ways to show this expression as well, but it's still going to involve making groups. So since the number on the outside of the parentheses is positive 2, we're going to show positive 2 by using 2 of those yellow tiles. So there's my positive 2. That's telling me I need 2 groups. And then we're going to show the 3x plus 1 also using tiles. So we're going to use 3 of those green x tiles and 1 of those yellow positive tiles to make 3x plus 1. So now I've got 2 groups of 3x plus 1, and all we're going to do is fill in these other 2 rectangles with like as many tiles as we need to fill that area. So let me show you what I mean. If I've got 3 x's across the top here, and I've got 2 rows of 1, basically I want to know how many x's am I going to be able to fit into this area. And I'm sure a lot of you already know the answer, but the answer is I'm going to be able to fit 6. So I can do 3 across the top and then 3 across the bottom, which makes sense because 2 times 3 is 6. And then we do the same thing with the yellow 1 blocks. So I've got 1 block up there and 2 blocks over on the side, so I can make 2 rows of a block. And from this, I can get the same answer that I got before. My final answer is I have 6 x's plus 2, but we'll show you how to do it in a couple examples here in a second. Okay. The other thing that we can do with tiles is we can combine like terms. And this is just an example of this expression all laid out. It says negative 2 x's. So we've got negative 2 x's over here. Positive 3, so we've got 3 positives down here, 3x, so we've got 3x over here, and then negative 5, so negative 5 over there. And I'll show you what some of these questions might actually look like on an actual test. Okay, this one says, which expression is equivalent to the picture? Now, one thing I want everybody to notice is that we have a key over here. So the red rectangles and the yellow blocks aren't labeled, even though you might already know what they are. They aren't labeled, so they have to give us a key. So each one of these red blocks is a negative x, and each one of these yellow blocks is a positive 1. But when I'm picking what expression it's equivalent to, I'm going to focus on how many groups I have and how many blocks are in each group. So I've got 1 group there and 1 group there for a total of 2 groups, which means A cannot be my answer and B cannot be my answer because neither of those say that I have 2 groups, but both C and D have that 2 there. Then I got to worry about what's inside the group. So inside each group, I have 3 negative x's. Okay, and it's funny to write it in that order, but that's how my brain is making me think about it. So that's how I'm going to write it down. And then I've got 3 positive 1s, which means my answer is D because that one matches. Let's look at another. All right, this is another area model, but we're going to actually do this one a little bit differently. Now, It doesn't have 3 X's and 2 negatives across the top and 4 like little ones across the side. It's just got these empty boxes. So what we're going to do is we're actually just going to fill in the boxes with what it would be. So I could draw, right, 4 rows of 3 X's. That's just going to take a while. So instead, I'm going to skip that part and I'm going to write down what that would give me. So either by counting them out or by using Desmos to do my multiplication, I know that if I have 4 rows of 3 X's, that's going to give me a total of 12 X's. And I'm just going to put that there. And if you wanted to draw 12 X's in that space, you could. But you might also be asked a question where you don't need to use blocks. You just put the number there. Okay. Then over here in the little part, again, I could draw 4 rows of -2 blocks, but that's already taking me a while. So instead, I'm going to go over to Desmos and I'm going to do 4 times -2, and that's going to give me -8. So this is just a different way to show distribution. And in another video, we'll actually solve it without the model. All right, I think we have one last question here. Which expression is equivalent to the picture? Again, we've got our key. This time we don't have groups that are displaying the same thing. So instead, I'm just going to write down everything we've got. I've got 3 negative x's. I've got 6 positive 1s. I've got a positive x. And I've got 3 negative 1s. Now, here's the problem. When I look at my answer choices, that is not an answer choice. So from here, I have 2 options. I can make a t-chart, or I can use my picture to simplify the expression. Now, I'm not going to make a t-chart this time because I'm going to do that in a different video. So if you want to know how to do the t-chart, check out 8.PFA.1b, which on your cards is like the next section. But instead, I'm going to cancel things out. So I know that this negative x, and this positive x are going to cancel out. In fact, let me get a different color so I can show you better. I know that they make a 0 pair, that one and that one. So they are gone. I also know I can take 3 of these positives here and cancel them out with 3 of these negatives. And then whatever I have left is going to be my answer. So now all I have left is 2 negative x's and positive 3 1s, which means my answer is C. And I think that means, yep, we are done.